Right, here we go. So, today we're talking about independent sample testing, where the population standard deviation is known. You're definitely going to need to have your Z-chart out for this. Okay. Okay, so two samples are independent when the sample from one population is not related to a sample from another population. So, an example of that would be the intelligence of a bunch of third graders, like IQ scores, and a bunch of fourth graders. If we want to compare third graders to fourth graders. Dependent samples are also called paired or matched samples. And for that, there's like a one-to-one correlation between a sample from one group and a sample from another. It can also be the exact same group. It can be like a before and an after. An example of that could be like an IQ of a parent and IQ of their child. There should be no confusion about if they're paired samples, there should be no confusion about who you should compare to each other. Like, let's suppose we were doing a treatment on weight loss. I wouldn't compare my before weight with your after weight. Like, the only thing that would make sense is comparing my own before weight to my own after weight. That makes sense? Same thing here, IQ of this parent and IQ of a child. You wouldn't be like, so who should we pair up to this parent? Their child is who that should be paired up, not anybody else. All right, so let's draw some pictures here. Independent samples, you got like one population over here, you got another population over here. Call this one population A, this one population B. You got some samples out of population A, some samples of population B. It can be the same amount or it can be different amounts. Like, notice I've got 5 people here, or 5 data points in my population A, and I've got 8 data points in my population B. Dependent samples, however, they have to have the exact same amount of samples in them. And they have to be paired, so like this one is together with this one is together with that one, and so on. If they're independent, they can have the same number of people in their sample or not, but dependent has to have the exact same. All right. So what do you guys think? Independent or dependent? Oh, I didn't, you guys want to win some Play-Doh today? I have Play-Doh. I don't think I offered it to you yesterday, did I? Probably not. Ugh. We'll get out the animals in a little bit. And by that, I mean, I'm going to ignore it until Emma gets it out and exasperate. Okay. All right, so what do you think? Independent or dependent, and why? 2 problems, 2 prizes, sound good? Who's up for it? Emma? It is. Why? Right, the height of men or males does not affect height of females. You definitely can't pair it together. There's no reason to compare exactly that guy with this girl and compare their heights. Okay. Who wants to do the next one? Mason.
It'd be the dependent.
Mm-hmm.
Because you can compare those students' midterms to their final.
Right, and it has to be like, now notice that there were exactly the same amount in both studies. If it's not the same amount, it's a red flag already, it's independent. Like, it's gonna be independent. But if they are the same amount, could be either, and this, you're comparing that your own, maybe not your own, but like Joe's midterm exam score with Joe's final exam score. Like, it'd make no sense to compare his final exam to a different kid's midterm. Okay. Go get prizes. You want some Play-Doh? A little bit? No. Surprising. Are you above taking Play-Doh, Mason? Oh, all right. Do it. Because you are. You are, very much. You getting out the animals? Yeah. Nice. All right. 2 sample independent mean test. So here we go. We're just going to do a quick one of these. And then I am going to go through the 2 examples with you and we'll be done. Okay. So first you have to verify that sigma sub 1 and sigma sub 2 are known. Anybody have an idea why we'd have 2 standard deviations this time? Because you've got 2 groups. Okay, they need to be normal or both of the ends have to be bigger than or equal to 30. Okay, these are in the problem.